there guys, this is Mr. Herbst here, and today our focus is going to be on the Doppler effect. Now the Doppler effect is actually a strange phenomena that is something that we have probably all observed at least one time in our life without really even knowing it. The Doppler effect is something that affects waves, water waves, sound waves, or light waves. Go ahead and check out this following video clip. I want you guys to pay close attention to the pitch of this car horn. Something very interesting happened as soon as that car horn passed our cameraman. We went from a high-pitched car horn to a low-pitched car horn. Now that happens because of something called the Doppler effect. Here's another great example. Sound familiar? The Doppler effect is something we have all observed at least one time in our lives. When the Doppler effect affects sound, we hear the pitch of a noise higher than it actually is when objects are coming towards us. And then suddenly, as soon as objects go away from us, we begin to hear that sound in lower pitch than it actually is. In music, we refer to our high-pitched sounds as our treble and our low-pitched sounds as our bass. In your car, you've probably seen these two knobs. The treble knob affects the high-pitched noises, and the bass knob affects the low-pitched noises. Now, the reason that we perceive these sounds as either being high-pitched or low-pitched is due to what we call their frequency. The frequency is otherwise known as how often the sound waves go past us. In this animation, you can see that the airplane is creating sound waves. It is very important to note that the airplane is moving. Therefore, as it moves, it is actually moving into the waves that it is creating. Therefore, the waves in front of the airplane have a higher frequency, thus having a higher pitched. And the waves behind the airplane have a lower frequency or a lower pitch. I'm going to go ahead and rewind our clip a little bit here. If you were standing right here listening to the sound of the airplane, you would perceive it as being a higher pitch. And as soon as it passes you, you would perceive it as being a lower pitched. The Doppler effect doesn't just affect sound, but it happens to affect any sort of wave, including water or light. Check out this picture of a duck. In this picture here, you can see a duck swimming. As the duck swims, it is actually swimming into the waves that it's creating. Therefore, the waves in front of the duck have a higher frequency because they're occurring more often. And the waves behind the duck have a lower frequency. They got stretched out due to the Doppler effect, and they occur less often. So as I've been saying, the Doppler effect doesn't just affect water or sound waves, it can affect light too, because light is a wave. You've probably seen this sort of color spectrum before if you ever use one of those little prisms and divided white light into its individual colors. You can see over here is red. Red has a bigger wavelength than these blue colors over here on this side. Therefore, if a light source was moving fast enough away from you, the waves of light would get stretched out. And if the light source was moving towards you fast enough, the light waves would get compressed due to the Doppler effect. We actually call that red shift and blue shift, but that's another video. Anyway here guys, this is Mr. Herbst. Hopefully you learned a little bit about the Doppler effect. I'm signing off folks. You all have a nice day.